Hello guys, this is Rakesh from Bodhee Prep, and in this video we'll be understanding the basics of logarithm. This is a very important concept in algebra. We must be having a sound idea about logarithm, how the rules work, right? And how these rules are interrelated with laws of indices, right? Because the questions which appear from the logarithm, they revolve around their properties and rules. So once we have understood the properties, that how these properties have come, right? We can apply that property as and when required to simplify the questions, right? Now, first of all, let us understand that why do we need logarithm as such? The need of logarithm was important before the calculator was invented, I would say, right? Because what happens is that if I want to multiply two big numbers, then that process is very, very cumbersome, right? It's very tedious process. Hard work is required. So the process of multiplication, if it can get converted into addition and some logic is applied into it, then we know that that hard work of multiplying two big number get reduced, and addition of any two number is anyways going to be simpler and easier than multiplying those two numbers without the use of calculator, of course, right? So logarithm is was all about it used to be useful because it converts the process of multiplication into addition, right? Also, it simplifies the process of division by converting it into subtraction. That is the beauty of logarithm. So it was quite useful before the calculator was invented, I would say, right? Now, how does it work and how it is interrelated with laws of indices? That is very, very important because all the rules are very much applicable or very much can be proved by using the laws of indices. Fine. So if I have any number, if I take any number, say 16 is equal to 2 to the power 4. Now, this is called the base and this is called the power. Logarithm is all about focusing on the power. If you find anything log of something, etc., it is basically targeting the power, right? So let's take an example that how multiplication is turned to addition and how the logarithm is used. Say I have two numbers 16 and 8 and I want to multiply. For a time being, let us assume that these are very two big numbers and I don't know the process of multiplication, or even if I know the process of multiplication, it is very hard, difficult. But I know that each of these numbers can be written as power of something. Say 16 can be written as 2 to the power 4 and 8 is written as 2 to the power 3. So can I say their product is as good as the product of these two? These two, I can apply the laws of indices to write it as 2 to the power 4 plus 3 because as per the laws of indices, a to the power n into a to the power n. Is nothing but equal to a to the power n plus n. So this is equal to 2 to the power 7. So I can say that 16 into 8 is nothing but 2 to the power 7. Somebody, he tried, what he did is that he wrote all the power of 2, the values of all the power of 2. He did the hard work one day, right? He wrote 2 to the power 1 is equal to 2, 2 to the power 2 is equal to 4, 2 to the power 3 is equal to 8, so and so forth, till say 2 to the power 100. He did something, right? And I have that piece of paper. So I haven't multiplied this. What I did is that I have applied the laws of indices. So I have added the power, right? And using that sheet of paper, I know that corresponding to 2 to the power 7, the number written was 120. So I'm just writing 128. So what I have done is that I have multiplied 16 into 8. The value is 128 by referring to that piece of paper. I have not multiplied, right? But I have added the power, knowing the fact that this is equal to this and this is equal to this. That is what I mean to say that the multiplication process was converted into process of adding the powers. Similarly, the process of division is converted to the process of subtraction. For example, 16 divided by 8. Suppose I don't know what is division, how the division is done. What I can do is that it is 2 to the power 7, sorry, 2 to the power 4 divided by 2 to the power 3. This is 2 to the power 4 minus 3, which comes out to be 2 to the power 1, or the value is 2. So I can say that the answer is 2 without actually doing this, right? So again, you can see that the process of division get converted into the process of subtraction. So division is converted into subtraction. Fair enough. So I hope you must have understood this. Correct? Now let us see what is logarithm then. In what format it is written. So if I write say x is equal to a to the power n, right? Then in logarithm, same thing can be written as log of x with base a is equal to n. So this entire thing is nothing but what is the power of the base. Okay. So if something is written like this, I can convert it into this and vice versa also. Fine. So let's do some example, because the difficult thing is not that logarithm is not that difficult, I would say. We face difficulty because we are not very much adapted to it. We have studied the laws of indices in our earlier school days. Logarithm get introduced later on, right? And at the same time, we don't give much importance to logarithm because there were other topics which were more important in the school days. That's why some of you who are feeling it quite difficult to understand, it is lack of practice or familiarity, I would say. So let us make ourselves familiar with the logarithm. As I said that this can be written in this particular format. So let us write down some numbers in this format and convert it into logarithm format. For example, if 8 square is written as 64, I can write in logarithm format. I know that this is the power and this is the base. So I can write it as log of, it will be written as log of 64 with base 8, and that is equal to 2. You can just check. Just compare. Here the value of x is 64, the value of a is 8, and the value of n is 2. X 64, a 8, value of n is 2. Right? Let's do some more. 3 to the power 5 is 243. Write down immediately in the logarithm format. This thing. This can be converted to logarithm format, which will be log of 243 with base 3, and that is equal to the power 5. Fair enough, right? Let's do one more. 2 to the power 10 is equal to 1024. If I convert, I can write it as log of 1024 with base 2, and that is equal to power 10. Right? Under root of 49 is equal to 7, we all know. We want to convert it to logarithm format. What we can do is that I can write this as 49 to the power 1 by 2, which is equal to 7, which will be in logarithm form. It will be log of 7 with base 49, because the base here is 49. And what is the power? 1 by 2. So this is another way of writing this in logarithmic format. Good enough, right? Similarly, say 27 to the power 2 by 3 is equal to 9. So we can write it as log of 9 with base 27 is equal to 2 by 3. Right? Next is log of 5 with base 25 is equal to, or let me take another example. It says 5 to the power minus 1 is equal to 5. So what we can write here is that log of 5 with base 5 is equal to the power minus 1. I think this is ridiculous. This is 5 to the power minus 1 is 1 by 5, right? So it is log of 1 by 5 to the base 5 is equal to 5, right? Good enough? Okay. So can we find the values of logarithm? Some values of logarithm. Let's see. If I have log of 32 with base 5, base 2, can we find this value? Let's try. What we can do is that, let us assume that this is equal to x for the time being. We know that this entire thing is nothing but the power which will go over the base, and the value would be this. So I'm converting it back to its radical sign, into the indices way, right? Base to the power of something. So I can write it as 2 to the power x is equal to 32. This is as good as this. Now we know that 32 is nothing but 2 to the power 5. If the base is same, can I say the powers will also be the same? So the value of x comes out to be 5, and that is what needed. What is that? Log of 32 with base 2. So this is equal to 32, and my job is done. Right? So you all can do in the same way. So I'm writing few examples. You will pause the video and you'll try it on your own, right? So I'm writing log of 9 with base 3. You have to find this value. Then log of, say, 125 with base 5. Next, log of 64 with base 4. Next is log of 5 with base 25. Next is log of 1 over 27, 1 by 27 with base 3, right? Log of 1 by 8 with base 8, right? I think this much is sufficient. Just pause the video and try to find the value of it, right? Okay, hope you must have done it, right? Every time what you have to do is that you have to compare it with x and convert into such format. So it will be 3 to the power x is equal to 9. Can I say this is nothing but 3 to the power 2? So the value of x will be equal to 2 straight away. So the value of this entire thing is nothing but 2. Similarly, in this case, assuming it to be x, 5 to the power x must be equal to 125, which is nothing but what? 5 cube. So the value of x is what? 3. Here again, if this is equal to x, then 4 to the power x should be equal to 64, which is nothing but 4 cube. So again, the value of x is 3. In this case, if this is equal to x, then 25 to the power x is equal to 5. Let us take it slightly in a detail. Okay. So 25 to the power x is equal to 5. I want that the base should be same both the sides. Base should be same both the sides. So what I can do is that this 25 can be written as 5 square whole to the power x is equal to 5. Or I can write it as 5 to the power 2x is equal to 5 to the power 1. Now the base is same. So can I say 2 of x is equal to 1, or the value of x is 1 by 2? And it's quite obvious now. 25 to the power 1 by 2 is nothing but root of 25, which comes out to be 5. So we have identified what is the power of 25, which will make the value equal to 5. It has to be root of 25. Root itself means 1 by 2. Right? Okay, let's see this. Log of 1 by 27 with base 3, assuming it to be x. So 3 to the power x must be equal to what? 1 by 27, which is nothing but 3 to the power x is equal to 1 by 3 to the power 3, right? Or you can write it as 3 to the power x is equal to 3 to the power minus. I'm using laws of the What is that? A to the power minus m is what? 1 by a to the power n. So reverse is also true. Here a is 3 and m is also 3. So I can write it as 3 to the power minus 3. Now comparing, we'll be getting the value of x to be minus. So this value is equal to minus, right? Now let's take this on a similar line. Log of 1 by 8 to the base 8. This will be equal to how much? Assuming it to be x. Right? So 8 to the power x is equal to 1 by 8. Or 8 to the power x is equal to 8 to the power minus 1. This rule. So the value of x is equal to minus 1. Now I hope you are a bit comfortable with writing things in a logarithm form and back to the original form. Good? Okay. Now let's take some more examples. Say log of 10 with base 10. We have to find these values. Log of 8 with base 8. Log of 5 with base 5. Log of 2 with base 2. Again, let us assume it to be x. Then 10 to the power x. 10 to the power x should be equal to 10. So this will give me the value of x to be 1. This 8 to the power x is equal to 8. Again, the value of x will be 1. 5 to the power x. Everything I am just comparing with x is equal to 5. So I will be getting the value of x to be 1. 2 to the power x is equal to 2. So I am getting the value of x to be 1. Every time I am getting the value of x to be 1. And if you observe them, you'll be getting the log of something is equal to the base of that log. Log of something is equal to the base of that log. So we'll make a rule or the end result that log of a with base a is nothing but equal to. Good enough, right? Okay. So this is one thing which you should be remembering, right? Next is, what is log of 1 with base 2? Log of 1 with base 10. Log of 1 with base 5. Let's try. Let us assume that this is equal to x. So 2 to the power x should be equal to 1. So can I say x has to be 0? Anything power to the power 0 is 1, right? Here again, if this is equal to x, so can I say 10 to the power x is equal to 1? This again is possible only if the value of x is equal to 0. This is equal to x. So 5 to the power x is equal to 1 is only possible when x is equal to 0. So here what we are finding is that logarithm of 1, irrespective of what the base is, always equal to 0. So log of 1 with any base is equal to 0 is the another end result which we have to remember. The first one was that log of a with base a is 1 and log of 1 with base a is 0. These are the two important end results. Right? These are not the rules, they are the end results. I'll come to the rules in some time. Fair enough, right? Okay. Now, let us come to the rules directly. So the first rule is log of x into y with some base, right? With some base, assuming to be, it could be anything, right? There is no need to specify the base again, but I'm writing it here like this. This is equal to log of x with base a plus log of y with base a. If the things are in multiplication, I can separate them with two different logarithms having the same base, right? Can we prove it? Let's do that. Let us assume that the value of x is equal to some number, say p to the power n, and the value of y is equal to some number p to the power n. Correct? I'm applying logarithm both the side. I'm applying logarithm both the side. So if I take p, then I have to replace it with a. So that's the guys. What we can do is that let us assume that x is nothing but a to the power n and y is nothing but a to the power n. Let us assume it. Correct? So if I multiply both x and y, I'll be getting a to the power n multiplied by a to the power n, which is nothing but a to the power n plus n by using laws of detachment. Good enough, right? So something is a to the power this. Writing it in the form of logarithm, can I say this can be written as log of xy to the power to the base a is nothing but the power which is n plus n. Right? This is the power, this is the base, and this is the overall value. So log of the value to the base is nothing but equal to the power. Now the value of n and m we can replace from here. We can replace from here. How? If x is equal to a to the power n, then we can say that log of x with base a is equal to n. Similarly, if this is given, then log of y with base a is equal to n. Substituting it here, you'll be getting that log of xy with base a is nothing but n can be substituted as log of x with base a plus this will be substituted as log of y with base a. This is by first. This is our first. If the two numbers are in product and we are taking log of it, they can be separated by separate log of those respective numbers, and we have to add them. The base will remain same in all the cases. This is my rule number 01. Right? Now let us see that can we simplify just by using this rule from value. So I have written some questions here. See, the first question is that we have to simplify or apply this rule only, because the application of rule is very, very important. Log of 6 with base 10, add it with log of 3 with base 10. We have to do this. Second, log of 4x plus log of x we have to do. Third, log of a plus log of b square plus log of c cube. You have to do this, right? Let's do. This is nothing but log of x with base a, log of y with base a, as you can see. So it will be log of x into y with base 10, or it can be written as log of 18 with base 10. So this is the conversion of this thing into this. We can do the I would say the inverse of it also. This can be written as this. Here, surprisingly, I have not written the base. So many times it happens that the base is not given. That doesn't mean that there is no base. If in any question the base is not mentioned and only logarithm is written, then it is assumed that the base is 10. If the base is not written, we assume that the base is 10. We don't need to write again and again 10. If it is 10, then we just write log of that, with an assumption that everybody knows that if the logarithm has no base written there, it is actually base 10, right? So I can write it as log of 4x into x with base 10, or we can write it as log of 4x square with base 10. Simple. I'm just applying the rule number 1. I'm doing it for your practice. This again, no base is given, but there are addition of 3. So how do I apply this? I'll just ignore the last one. For the time being, I'll just do this. What do I get? It will be log of a into b square with base 10 plus, I'll write the third one like this. Again, I can apply the same rule, right? Because this thing will become this thing will become this. So overall, their sum should be equal to this, which is nothing but log of a into b square into c cube with base 10, right? So from here, this rule is, we can observe that this rule is not only for two numbers or the product of two numbers. It can be for more than two numbers also, right? The same cascading effect we have to apply. So this is about rule number 1 and its application. We have seen that we can apply it to simplify this. Now let's move to the rule number 2. Rule number 2 states that if we have to find the log of x over y, x is divided by y, have a base 10. This is nothing but log of x with base 10 minus log of y with base, right? Again, let's prove it. If the value of x is a to the power n, we can say that log of x with base a is equal to n, and the value of y is a to the power n, then we can say that log of y with base a is equal to n. Now I'm multiplying x into y, so I'm getting a to the power n into a to the power n, which is nothing but, sorry, I have to divide it now. I have to divide it. If I'm dividing x by y, then I'll be getting a to the power n divided by a to the power n. Again, I can write it as a to the power n minus a to the power n minus. I'm using log of indirect, correct? So we can say that x divided by y is nothing but a to the power n minus n. Now I want to convert it and write it into the logarithm form. This is the power, this is the base, and this is the overall value. So log of the value over the base a is nothing but the power, right? What is the value of n? The value of n is log of x with base a minus m is log of y with base a. This is my rule number 2. This is my rule number 2, as you can see, right? This is not necessarily 10, it could be any base. Fair enough, right? So we have taken 2 end results and we have seen 2 rules. For this rule, let us do some practice. In fact, what we can do is that we can take the same values, right? Instead of the addition sign, we can take the division. Instead of addition, we can take the division, right? So I'm just ignoring the last one for the time being. So what we can do? This is minus, this is minus. Fine. So this is log of x minus log of y with base 10. This is nothing but equal to log of x over y with base 10, which is nothing but log of 2 with base 10. This is the simplification of it. Similarly here, it would be log of 4x divided by x with base 10. So x will get cancelled out, so we'll be getting log of 4 with base 10. This is the application of rule number 2 when there is a minus sign. For plus sign, we have to apply rule number 1. Good enough, right? Okay. Now let's change this level. Next, we have to focus is rule number 3. Yes, rule number 3 is very, very important. So what is rule number 3? Rule number 3 says that log of x to the power m having a base a can be written as m into log of x with base a. Here m is multiplied to the entire. M is multiplied to the entire, right? Let's prove it. Again, let us assume that x is equal to the, I have taken this now. Okay. X is equal to, I'm going to draw. A to the power n, right? I am taking the power, or I'm raising power m to both sides. So I'll be getting x to the power n is equal to a to the power n whole to the power n, right? Now I want to write this in the logarithmic format. Logarithmic format with base this a. Now I want to take logarithm both the sides. Or what we can take is that both the sides we can take by base a. Let me simplify this. This will be a is equal to a to the power n into n, right? Now this is some number n, which is equal to a to the power n into m, correct? So in a logarithmic format, I can write it as log of n with base a is equal to n into m. Fair enough? You can just check on your own. I'm replacing n with x to the power n. So log of x to the power n with base a is nothing but n into m. Or I can write it as m into n also, right? I can write it as m into n. Now what is n? What is n? If this is given, can I say log of x with base a is nothing but equal to n? So we can replace it here. So this is nothing but m into log of x with base a. So now I have proved the third rule as well. That log of x to the power m with base a is nothing but m into log of x with base a. So what happens is that this power gets from here and multiplied with the logarithm. That is what happening in the, this power is effectively getting multiplied with the power which is inside this bracket. This portion itself is the power of a, for which we are getting the value of x. Getting it? So this is rule number 3, very, very important. So let us do some examples. We have to convert from one format to another in logarithm itself using the rule number 3. So 3 log of 5 with base 10, right? 2 log of x, log of 4x whole square, and 5 log of 4 square. Let's do it. This we can write it as this 3 will go and become the power of this, right? Because log of x to the power m to the base a is nothing but m into log of x with base a. Similarly, this will be written as log of x to the power 2. This can be written as 2 log of 4x. So I'm just converting from one format to another. Either it is the LHS is given, then I'm converting to RHS and vice versa. Here I can have both the options. If I can take 2 here, it will become 10 times because 2 will be multiplying with 5. And here it will be log of 4. Or what I can do is that I can take 5 and make it power. So it will become log of 4 whole square to the power 5, which will make it log of 4 to the power 10. So I can write it both the ways. Fair enough. So this is rule number 3. Now, let us solve some logarithm question again. We have to get the value of log of 512 to the base 2. Next is log of 1 by 64 with base 8, log of 5 with base 25, and log of 25 with base 5. Let's do that. We can apply the logic. This, we know that 512 is 2 to the power 9. So I can write it as log of 2 to the power 9 with base 2. Now I can apply rule number 3, which is nothing but 9 into log of 2 with base 2. Correct? Now what is log of the number having the same base? If you remember, I gave you the end result that log of a with base a is nothing but equal to 1. So this entire thing becomes 1, which is nothing but 9 into 1 or 9. So the value of this is nothing but 9. And it's quite simple, no? 2 to the power 9 will give me 512. Right? Again here, log of 1 by 64 is equal. So can I write it as 64 to the power minus 1? Right? A to the power minus n is equal to 1 over a to the power n. Correct? And in fact, this is not required. Yes, a to the power n. Okay, sorry. Very well, it can be done. 8. And here I can write this as log of this 64 is nothing but 8 square. So this will become 8 to the power minus 2, because 64 to the power minus 1 is nothing but 8 square to the power minus 1, which will make it 8 to the power minus 2 and basis 8. So again, applying the rule number 3, which will make this and come to the multiplication portion. So it will be minus 2 times of log of 8 with base 8. This will become 1, or the value is 1. Let's do this. Log of, this is base 25, right? So what we can do is that we can write it as 25 to the power 1 by 2. 5 can be written as 25 to the power 1 by 2. Correct? So the value would be half of log of 25 with base 25, which comes out to be 1 by 2. Good. This log of 5 square with base 5. So this is 2 times of log of 5 with base 5. Rule number 3. This will be equal to 2. Now observe that here we are finding log of 5 with base 25. Here we are finding log of 25 with base 5. And their values are reciprocal to each other. Their values are reciprocal to each other. So from here, what we can say is that we can come up with rule number 4. We can say that the rule number 4 is that log of a with base b can be written as 1 over log of b with base a. If I want to interchange, I have to interchange using this method. Why so? Because you can just see if this is a and this is b. Here this is b and here it is a. This value is 1 by 2 and this value is 2. So this is reciprocal of this, or this is the reciprocal of this. Good enough, right? So this is my rule number 4. Let's do some practice. Log of 625 with base x is equal to 4. You have to find the value of x. You have to find the value of x. Very simple. There is no need of any rule. You can just convert it into basic format, which is base and power. This should be equal to 625, which is nothing but equal to 5 to the power. If the power is same, so the base need to be the same, which will give me that the value of x is equal to 5. Good enough, right? If I want to apply the rule, then also we can get it now. How? We know that 625 is nothing but 5 to the power 4. Right? Again, applying this third wala rule, we'll be getting it as 4 log of 5 with base x is equal to 4. Right? We can take this 4 on the RHS, because this is nothing but 4 into something, right? So this will make it log of 5 with base x is equal to 4 divided by 4, which is equal to 1. I give you an end result. Log of 1 with base a is 0. Log of a with base a is equal to 1. This is this case. That means both these values should be equal. So we can say that the value of x has to be 5. Either you do this or you do this, you'll always be getting the right answer. The good thing is that just convert logarithm into its fundamental form. Things become very easy. Good enough, right? Sure. Let's move to the next. Let's take the one more example I have written. Here it is log of x with the base as, let me properly. Log of x with base 20, root of 27. This is equal to minus 4 by 3 and you have to get the value of x. You have to get the value of x. If any complexity comes to 1, get rid of logarithm. Just convert into this basic form. This is the base under root of 27 to the power should be equal to this, right? Now just apply laws of indices. This can be written as under root of 27, right? So it will be 27 to the power 1 by 2 whole to the power minus 1 by minus 4 by 3 is equal to x. So this is 27 to the power 1 by 2 multiplying by this, it will be minus 2 by 3. This is equal to x. Again, 27 can be written as 3 cube minus 2 by 3 is equal to x. This can be written as 3 multiplied by this will make it minus 2 is equal to x. Correct? So this can be written as 1 by 3 square, which is nothing but 1 by 9. So 1 by 9 becomes the answer for this x, or the value of x is 1 by 9. Fine. Okay, so what next? There are a few more examples, I think. For example, okay. Let's take the next rule, rule number 5. Rule number 5 says that log of a with base b, right? This can be converted into some third base. Here the base is b, and I want some third base. So it would be log of a. Suppose I want to change it to base c, then I have to write it this way. I have to write it this way. This is change of base. This rule is called change of base. Right? Again, it's very nothing difficult. What we can do is that let us assume that log of a to the base b is y. Can I write it as b to the power y is equal to a? Right? Let us apply to base c, logarithm of base c both the side in this. So I'll be getting log of b to the power y with base c, and here I'll be getting log of a with base c. Right? This I can apply the third rule wherein y will get into the multiplication. So it will be y into log of b with base c is equal to log of a with base c. Or I can say that the value of y would be log of a with base c divided by log of b with base c. And what is y? This now. This is y. This is also y. This is also y. Here is the rule number 5. You can change the base. This, right? Let's take one example to make it understand. The log of 32 with base 4 we have to find. Applying the rule number 5. We are deliberately want to apply the rule number 5. We know here is that both 32 and 4, they comes in some power of 2. 32 doesn't come in the power of 4, but 32 comes in the power of 2, and 4 also comes in power of 2. So why not change the base from 4 to 2? I can write it as log of 32 with base 2 divided by log of 4 with base 2. Right? You can just compare. This is my rule number 5. A is 32 and B is 4 and C is 2. This is very simple to do because this one 32 is nothing but what? Log of 2 to the power 5 with base 2. Here it will be log of 2 to the power 2 with base 2. Separately, I want to find the numerator portion. This comes out to be 5. It will be 5 into log of 2 with base 2. Having the same base of that number, it will become 1. Here it will become 2. So the answer is what? 5, right? As I said, not necessarily that we have to apply the properties of logarithm. We can work such kind of example without the help of logarithm property. We can convert it into its original format. We can assume that this is log of 32 with base 4 is equal to x. This is actually equal to 4 to the power x is equal to 32. Right? So 2 to the power 2 whole to the power x is nothing but 2 to the power 5. 2 to the power 2x is equal to 2 to the power 5. Base is same, so the power should also be same. That will give me the value of x to be 5 by 2. You can compare. So either you can apply the properties or you can convert it to this. So you might be thinking, sir, do we need to understand or learn this property and apply this? Then the answer is yes. Because right now I'm giving you a very simple questions. Once the complexity of the question increases, then the property will be more helpful than the original. Good enough, right? Okay. There is one more thing I just missed. I need to clarify that. Say log of -8 with base 2. Can we find this way? Let's try. Let us assume it to be x. We will not be applying properties. Let us try in its original format. So it will be 2 to the power x is equal to -8. You just tell me, is it possible? Can we have any power of x? Either a positive, negative, fraction, whatever. Such that 2 to the power that power will make it negative. The answer is no. The answer is no. Even if I take it positive, overall value will be positive. If I take it negative, for example, if I take it to say like this is not equal to -8. This is effectively 1 over 2 to the power 3, which will make it 1 by 8. Yes or no? So such possibility is, or there is no possibility where I'll be getting some real value of x, which will satisfy this equation. Never. It will never happen. So what can I infer from here? I can infer from here that we can't find the log of a negative value. Log of a negative value is not acceptable. You can check. Nowhere I have taken a negative value of it. It was always a positive. The negative value of a log on log of a negative value, sorry, log of a negative value is not allowed in logarithm. Right? Do remember this. Okay. Let's move to one question which will just explain you that how these properties are used. We'll be having one more video on logarithm wherein I'll extend the property and I'll take some more complicated question and I'll apply the properties also, help you to understand that how these application of properties reduces the or simplifies the logarithmic expressions. So there is one question I have written here. It is log of 32 by 3x, sorry, 3x, not 32, 3x plus of 2 with base 10 minus of 2 log of x with base 10 is equal to 1 minus log of 5x minus 3 with base 10. Right? We have to simplify. Simplifying this is we have to get the value of x. We have to solve and get the value of x. What can we do? Let it be as it is. Log of 3x plus of 2 with base 10 minus this. I'm applying rule number 3. This should go into the power of this. So this can be written as log of x square with base 10. Right? This is equal to, this can be written as log of 10 with base 10. One can be written as, so these are all the examples of manipulation which we do. Minus log of 5x minus 3 with base 10. The purpose here is that I have to take everything, every logarithm terms as base 10, right? So that I can apply rule number 1 or rule number 2, depending upon their application, right? So what I can do here is that I can take this as log of x minus log of y, which is nothing but rule number 2. This is 3x plus 2 divided by x square with base 10. Here again, this would be log of 10 divided by 5x minus 3 with base 10. Now again, the base is same, so we can directly compare the values. So it will be 3x plus 2 divided by x square is equal to 10 divided by 5x minus 3. Let's solve this. So we have got rid of logarithm. So let me just take space here and solve this. So taking the multiplication, I'll be getting it here as 15x square. This multiplied by this. This multiplied by this will be 9x. This multiplied by this will make it 10 of x. This multiplied by this will give me minus 6. Correct? This will be equal to, here it is 10x square, straight up. So 10x square subtracted to 15x square will make it 5x square. This two together is plus of x minus of 6 is equal to 0. Now this is a quadratic equation, right? So let us spread the terms. 5x square plus, I need to split x such that 5x square minus 6, minus 30 should come. So the good way is that it should be written this way. The product of these two is nothing but 30x square and their sum is equal to plus of x. Here we can take x common, so it will be 5x plus 6 minus it will be 5x plus of 6. Correct? Further, 5x plus 6 is common, so it will be x minus 1 is equal to 0. So we have factorized it. So either this will be 0 or this will be 0. If this is 0, then the value of x, that is 5x plus 6 equal to 0, I'll be getting the value of x is equal to minus 6 by 5. If this is 0, then the value of x would be equal to 1. So are we getting two values? The answer is no. That is the most critical thing in logarithm. Whatever the value I am getting, it must satisfy the properties of logarithm as well, or it should not violate any condition of the logarithm. X is equal to 1 is acceptable. You can see, if I put the value of x equal to 1, this will be positive. This is positive. This too would be positive. So this is acceptable, but this is not acceptable. X equal to minus 6 by 5 will make this portion as negative. It will be 2 log of minus 6 by 5, 10. It's not defined in logarithm. As I said that logarithm of negative value cannot be identified, right? But you will say that, sir, here it is written like this. If it is written with an assumption that you will not be taking any such value of x, so that for which the logarithm is not defined. Because of that reason, although I am getting this the value of x, this is a part of quadratic equation. But to be a part of the entire question, this would also satisfy the logarithmic property or the rules of the logarithm, which it is not following. So we'll be discarding this value of it. So the answer for this is x is equal to 1 only, not the second value, right? So the answer here is that x is equal to 1 is the only value which will satisfy. Fair enough, right? Okay, so I have taken rule number 5. There are further more rules, but those rules are just they build on those the first 2 or 3 rules, right? Even if you don't know those rules, you'll not be losing anything. But yet I'll be discussing it because if there is some complicated question, you can just apply those rules to simplify it with, right? Okay, so I'm just resting this session here itself. In the next session of logarithm, I'll be taking some more examples.